that I loaded into or my Notre Dame, right? The 12.3 was 12.2. So I fixed that. Can somebody just like quickly confirm that I meant to fix it anyways this morning. That's good? Okay. Thank you. And now we're going to stop for announcements, it sounds like. No, maybe that's just a warning bell. Okay. So my apologies to that. I went and checked for homework. I put things as missing. Just try to finish it this week. You know that I don't care if it's within 7 days or whatever. You know, like, I get it. I mucked that up. So that's my fault. All right. So today, the goal is to kind of do the 23 in-class examples. Since it doesn't seem like anybody would have had a chance to look at the 12.3 PowerPoint either, we'll kind of talk about that as we go, and kind of jump back and forth a little bit. I'm not going to do the whole PowerPoint because, well, I'm not going to do the examples because they're here. And to some extent, I'm just going to kind of talk more so than read through the PowerPoint. Is that okay with you guys? Okay. So the 12.3 is about another type of probability distribution called a normal distribution. Now there's two pieces of vocab involved. There's a normal distribution and a standard normal distribution. We'll talk about what the difference is here in a second. This is like fundamentally different from a binomial distribution in that a binomial distribution is what we call a discrete distribution, meaning that like you can have 5 successes or 6 successes, but you can't have 5.5 or 5.1 or 5.2, right? Like your successes are discrete values. Like there's no decimals or whatever allowed. Everybody's okay with that idea? In a normal distribution, this is a continuous distribution. So any decimal point is available. As a result, the probability of any single event in a continuous distribution is 0. Because if there's infinitely many things possible, the probability of one thing happening is 0, because 1 divided by infinity is 0. So when we talk about a continuous distribution like a normal distribution, we're always going to be talking about the probability that you're between two values, or bigger than a value, or smaller than a value. And when we talk about these continuous distributions, again, because a single score has a probability 0, there's no difference between the probability that x is greater than or equal to 5 and x greater than 5, right? Is everybody okay with that idea? So, blah, 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 blah. So when we talk about representing one of these continuous distributions, we use a density curve. So if I have a symmetric distribution, the mean and the median should be exactly the same spot. If it's skewed, that will affect the mean more than the median. So they'll both be pulled towards the skew, but the mean more so than the median. Again, this was an idea that we saw in first semester when we talked about we did like the t-test and chi-squared, right? So a normal distribution is a type of symmetric distribution. So all normal distributions are symmetric. So the middle spot is the mean. And often we're classifying the distance from the mean to the first standard deviation or the second standard deviation or the third standard deviation. Remember that mu symbol is the symbol for mean, and that sigma is the symbol for standard deviation. So when we identify a normal curve, we say x is distributed n for normal, and then we list the mean and the variance, that's the standard deviation squared. So that's the kind of our identifiers. And again, like normal distributions are often a good description for real life events, like, you know, like heights of individuals tend to be normally distributed, or weights, or like ages in a population. You know, lots of things like this can kind of follow, well, maybe not ages, but can follow a normal distribution curve. All right. So this is something that you should have memorized. This is the 68, 95, 99 rule. What this says is between the first, or one standard deviation away from the mean, so here's a normal curve, we're going to say 0 is the mean. If I go one standard deviation to the right, and then one standard deviation to the left, the area under that curve is 68%. So the probability that any outcome is between, or is within one standard deviation of the mean, is 0.68. Is everybody okay with that? Which means that the section between 0 and 1 is 0.34, and the section between 0 and -1 is also 0.34. Everybody okay with that? So the 95 says within 2 standard deviations of the mean, so from -2 to +2, that's 95% of the data. So if we knew 68 was here, in these two little teal sections is got to be the other 27%. Everybody okay with that? 95 minus 68 is 27. So 13.5% here and 13.5% here, but this is going to be representing 95% of the data. And then the last 99.7 is within 3 standard deviations of the mean. So again, that's the difference between 95 and 99.7 is 4.7. So that means there's like 2.35 here and 2.35 here. Everybody's okay with that? So if I ask you how much of the data is between -1 and -3, well, there's 2.35 plus 13.5, and you're done, right? Or if I ask you between -2 and +1, 13.5, 68, add those together, you're done. Is everybody okay with that? You're going to have those 68, 95, 99 memorized, though. That is something that the IB will expect you to have memorized. There's not a lot, but that's one of those. Okay, so let's just take a quick look at these 3 normal distributions. Notice each one of them has a different mean, but they have the same variance. That means that the curves are going to be the same width. It's just the location of the center of the curve is going to be different, because the location of the center should be lining up with its mean. But the width of the curve, how spread out it is controlled by the variance. Is everybody okay with that? So if I see 2 curves that have the same variance, I know that they're going to be exactly the same shape. They're just the center of their location is going to be different based on their means. What if I have the same mean but different variances? Well, they're going to all be centered at the same value, but the width, how spread out that curve is going to be different. So the bigger the variance, the bigger the spread out. Everybody's okay with that? And notice that because we know what does the area under this curve have to be exactly? if they're probability functions, has to be 1. Remember that like a probability distribution is, the total probability is 1. So to keep the area under the curve constant to 1, if it's spread out further, its height has to be shorter, right? So like x3 isn't nearly as tall as x1 because x3 is really spread out and x1 is, not very spread out, but they both have the same area under the curve. They're both still 1. So blah, 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 blah. Yeah, typically we're going to be talking about finding like the probabilities that it's like x is less than 5. So we're talking about this blue shaded area here. To actually calculate that by hand requires calculus, not in this class though. We're going to be using our calculator. And then this is what I mentioned earlier, that it doesn't matter if it's less than or equal to, right? That they all have the same probability because the probability of an individual score in a continuous distribution is 0. So the Pth percentile, remember this from first semester. So it says Jenny earned an 86 on her test. How did she perform relative to the rest of the class? Oftentimes we'll discuss this in terms of a percentile. Remember, there is no 100th percentile. So if we looked at 86 was bigger than 21 out of the 25 scores, and if I convert that to a percentage, that's 84%, 21 out of 25. So we were the 84th percentile. Everybody's okay with that? Remember that from first semester? What if, like, you're taking a test and you have Mr. Kulik and someone else is taking a test and they have, like, Miss Garcia, and they're like, hey, what'd you get on your test? It's, I got a 15, and the other person's like, I got a 19. The question might be who actually did better, because the class averages for the two classes might be very, vastly different. So a way to compare measurements in two different probability distributions is with something called a z-score. So to calculate a z-score, we take the measurement, we subtract the mean and divide by the standard deviation. So if I do the same thing for Jenny here, let's say her class mean was 80 and her standard deviation was 6.07. We ask what is her z-score. We do 86 minus 80 divided by 607, so it's basically 0.99. If we take all the data in our data set and we convert them to z-scores, the resulting probability distribution will be what we call a standard normal distribution. So when you hear standard normal, all that means is now the mean is 1. The mean is 0 and the standard deviation is 1. So when you hear standard normal, all that means is we took all of the data and we just converted everything to a z-score. So if I take the mean, I do mean minus mean divided by standard deviation. Well, that's 0. And because everything is once being divided by standard deviation, the standard deviation is 1. Okay, so that's when we say standard normal distribution, it just means mean is 0 and standard deviation is 1. So if I want to do areas, actually, let's just go to this now. All right, that's probably enough. The rest of this is going to be calculator work, so I'm going to dump the examples now. Or dump that anyways. Okay, in 2012, the mean number of wins in Major League Baseball was 81, with a standard deviation of 11.9 wins. Find and interpret the z-scores for the following teams rounded to 3 sig figs. Take out your calculator. Try to do that. Again, remember z-score was score minus mean divided by standard deviation. So I got 1.18 and then negative 5.88 for my two z-scores there. What a z-score here would be really effective in doing is, say you wanted to compare how successful one team was in 2012 with how successful they were in 2013. You could take their wins and the means and standard deviations for each of those two seasons, convert them to z-scores, and then compare the z-scores. And the bigger z-score would indicate you were more successful relative to how difficult the league was in that season. Does that make sense to everybody? So oftentimes, like, this is a good comparison if you're comparing two pieces of data that were collected under different circumstances, right? So if you took test version A and you took test version B, and you want to say, oh, who did better on their test? Well, you can convert your scores to z-scores and then compare. Okay. The table below gives the home run totals, mean home runs for the entire Major League Baseball, and standard deviations for 4 years when the home run record was set in baseball. Which of the players had the most outstanding performance relative to his peers for the given year? So what does this sound like we should be doing? Yeah, I'd be making z-scores. How many z-scores are we going to compute here? 4. Any baseball aficionados kind of know where this is going to be heading? Mr. Kulik suspects each year it's going to be getting less and less impressive. Okay, so I got 5.44, 3.15, 3.88, and 3.91. So how would we interpret that? That would basically be our ranking, right? Just FYI, what is this z-score really saying here? What does this 5.44 really mean? Means that 60 home run statistic was 5.44 standard deviations from the mean. That is just a tremendous outlier of a season, right? Like if you go back and we look at the, like this thing that looks like our normal curve, you're talking about like something like way the heck out here, which is just like a stupendous, like 3 standard deviations is a monster. like outlier. 5 standard deviations is just absurd. All right, let's go to the next one here. A survey was conducted to measure the weight in pounds of the backpacks at a high school. 85 total students were used in the survey. Suppose the distribution is normal with a mean of 8.5 and a standard deviation of 0.71. Use your GDC, blah, 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 blah. What is the Z-score with someone whose backpack weighs exactly 9.8 pounds and then exactly 4.5 pounds? Tell you what, Mr. Kulik would be asking is, what's that person with the 4.5 pound backpack? How much homework are they really doing here? So if I look at the Z-scores, I would have got 1.83 and then negative 5.63. That's a monster outlier in the bad direction, right? Like you're 5 standard deviations under the mean. I'm guessing that person's not getting a lot of homework done if their backpack is that light. Or maybe they're just really efficient, you know? They're the kid that just like sits in class and absorbs all the content without writing anything down ever. And they're just like, everything is perfect and they don't really have to try very hard. I don't know anybody like that. Okay, next one. It says, for the question below, rewrite the question using the appropriate notation. So that means rewrite it as a normal distribution, like X, squiggly, N, mean and standard deviation. Provide a sketch of the normal distribution curve and shade the indicated area. Then use the normal CDF function on your calculator to evaluate to 3 significant figures. So we'll show you how to use the calculator in a second. Okay. So the standard normal, 0 and 1. Everybody's okay there? And then I want the probability that negative 0.58 is less than Z. I guess we can use Z because it's a standard normal, right? Instead of X. That's pretty common. So that's kind of what I'm going to write. And now I'm going to go to, if you want to follow along on your calculator, I'll show you how to use this normal CDF function. Second, and then vars. And then right there where it says normal CDF, option 2, I'm going to pick that. The lower value is negative 0.58. Oops. Except I had apparently a little brief dyslexia there. And then 1.79. And the problem tells us since it's standard normal, the mean is 0 and the standard deviation is 1. So I just press paste and enter. And I get 0.682. Is everybody okay with how we got that? So in the next one, Z is normal, 0, 1 squared, because again, it says standard normal. And we want the probability that Z is greater than 1.53. Bless you. So again, I'll do distribution or second vars and then pick normal CDF. Now, the lower bound is going to be 1.53. What's the upper bound going to be? Right, it said Z is greater than 1.53. What should the upper bound be? In reality, it should be positive infinity, right? Can I type positive infinity into my calculator? No. So what I'm going to do is I'm going to type the biggest number I can into my calculator. So I'm going to press 1 and then second, comma. So 1 times 10 to the 99th. So I do 1e99. Again, this was standard normal, so 0, 1. And then we'll paste that and press enter. So I get 0.0630. Again, I'm wanting to round to 3 sig figs here. Okay, let's do the next one. Proportion of standard normal. Okay, so 0, 1 are less than or equal to 0.62. So same thing, normal CDF. Now what should the lower be in this case? Negative infinity, so I'm going to do negative 1, and then second, comma, E99. And my upper this time will be 0.62. Hold on, got to be careful here. Below the mean, right? 0.62 below the mean. So I really mean negative 0.62. Whoop! Almost got me, Mr. Kulik. Reading the whole question is to your advantage. Again, 0, 1, because it was standard normal. So I get 268. Is everybody okay with the extra little piece of, yeah, it's kind of, I just got to be careful. All right, next one says standard normal. So 0, 1. And the probability that that scores within 1.24 standard deviations of the mean. So how do I write that? Well, it could be 1.24 below or 1.24 above, right? And I think if you did that with a greater than or equal to or just regular equal to it, I don't think they would have cared. So again, second, vars, normal CDF, negative 1.24, positive 1.24, still 0, 1 because they're still standard normal. So it's 0.75 or 785. Okay. Oh, we should be, the guy said was asking us to draw pictures here, huh? So we should have done that, huh? So this one would have been like, you know, something like that, where that's Is everybody okay with what the picture looks like? It's just like a normal curve, and we're just drawing the shading of what we're doing, right? Does that feel okay? All right, I forgot to do that. My apologies. I just got excited about the math. All right, this last one, the wording is kind of funny here. So let's think about what this is going to mean. So standard normal are greater than or equal to 0.77 standard deviations away from the mean. So let's think about the picture maybe first. would be that, right? So if I wanted to write that as a probability, could write it that way. Or you could write it as that you guys buy that? So it's the stuff less than 0.77 plus the stuff greater than 0.77. And that's how we're going to get into our calculator, right? Is I'm going to have to do this as two normal CDFs. So I'll do the little one first. Oops. Just forgot that negative sign. And then plus that, do both of them. I got 0.441. Can anybody tell me something that they would expect about these two probabilities? Let me give you a hint. Your normal distribution curve is symmetric. So they should be the same probability. And I think if we did this on our calculator and just did one of them, that's exactly what we would find. So I'll just delete down and just do one of them. And that is exactly half of what I have here, right? So if you made that observation, you could have just done one on your calculator and multiplied it by 2. Not wrong to do that. So far, so good? Is this not too bad, right? You just have to be able to read the question, know what to do, and like be able to do something on your calculator. All right, question 5 is the same kind of idea, except instead of giving you a standard normal distribution, you have just a normal distribution, but that's not a big deal. Oops. So x is normal 67.54, comma 384 squared. And then we want the probability that x is between 68 and 70. So that would be like over here. So second VARS, normal CDF. So 68 to 70. But this time my mean and standard deviation are different. They're given to me. So that gives me 0.191. What's the alternative thing you could have done here? You could convert those two to z-scores and then use a standard normal distribution. I don't know why you would want to, given the graphing calculator technology that you have available to you. When I did this as a high schooler and we did not have a calculator that did this, You know how we figured out these probabilities? We had to look them up off of a table of standard normal values. So you had to like track, you converted everything to a z-score, and then you had to like track on the table and like find out where the value it is, and like, okay, so it's going to be this value minus that value, and like it was there. I had to. I don't see any reason why you would have to in this case, but like you could, is all I wanted to say. All right. Somebody try this one on next one on their calculator and see what they get. It's a race. I'm done. Anybody beat me? Oh, it gives me the thing in there. I'm not going to bother writing it then. Did you guys get 0.662? Rounded to 3 sig figs. No? I'm seeing a lot of no response and sad looking faces.
What numbers did you put in, Mr. Pollard?
Yeah.
Oh, I forgot to type in the things that you have. Oh. There you go. That'll do it.
Let's try the next one.
We might give you guys yes. What am I typing? What numbers did you put?
Oops. So I did. Yes, of course.
Okay, I was so close.
So again, like this is a skill you're really going to have to be able to do. Like take the question, get it to your calculator, get the calculator to give you the right probability. Like if you're not good at this yet, that's okay. But like when you're doing the homework, make sure that you're doing this correctly. Like a little bit of calculator literacy here goes a long way to like getting a whole slew of answers, because none of these questions are tremendously difficult. It's just about like, can I get the information into my calculator in the right way? And the calculator will handle all the heavy lifting for me. I just got to get it set up correctly. All right, let's do D. How do we do? Based on your giggles, I'm guessing not great.
Not inconclusive.
Okay, so read this last sentence for me. Within 0.8 centimeters of the mean. So what's the lower bound have to be? Mean minus 0.8. What's the upper bound have to be?
Plus
Mean plus 0.8. So again, reading comprehension.
I read it, it wasn't comprehensible.
Yeah, so it's a two-way street, right? You can't just read it and not understand it. Like, read it a couple of times if you need to make sure you understand what it's saying is going on. Draw the picture. Often that'll really help you. Okay. All right. Let's do E. Again, try it on your calculator. So you have to do, oops, I guess that's the D is our random variable. Right, because it's more than 10 miles away, so you could be 10 miles less or 10 miles more. So if you had half of it, you just did one way and not the other. You forgot that, like, oh, I could be 10 miles short versus 10 miles over. So again, like, if you draw your thingamajigger, here's 38.9, that's our mean. So you could have one that was 28.9 here and one that's 48.9 over there. Right, so you have two pieces. Right. So again, like, as you go through and do the homework, like, really do this homework based on what you're showing me. Don't just copy down the answers out of the back of the book. Like, sometimes it appears that we are in the mood to save some time. It's like, yeah, I got it. I'm just going to copy these down. Really do this one, because there's not much to write down, right? Like, it's not asking you to write a lot. There's no work to show. It's like, literally, can I get this into my calculator and get the right number to come out of my calculator? Because there's not much partial credit I can give you. You know what I'm saying? So you really have to be able to do this correctly. All right, let's look at this one, number 6. In a recent tournament, Rafael Nadal averaged 115 miles per hour on his serves. Assume the distribution of his serve speed is normal with a standard deviation of 6 miles per hour. Use your GDC to estimate or to answer the following questions. What percent of Nadal's serves would you expect to exceed 120 miles per hour? Go. Oops. Yep, I'm so dumb. Okay. Okay. Try the next one. You guys okay with how I got that, though? Did some of you guys get that? I'll take it. I'll be excited for one or two of you to have gotten it, because it seems like we're just having a hard time with this right now, and that's okay. That is okay. We're starting to get it. Yeah, I'm excited. I'm excited, especially because, like, it's a new skill. It's not easy. All right, let's look at 7 then. It's a lot of crying. No more than 17. Would 16 be no more than 17?
Yeah. Okay. It's
Like,
weird that you say it.
Not more? Well, I'm trying to
Yeah, right.
cook through the different ways you can say less than and greater than. So it's just so you're familiar, you see the different ways that a numbskull could ask this question, right? Not that I'm a numbskull, but
It's not you, Mr. Cole.
I just don't want to feel like I'm tricking you when I use different vocabulary that I haven't heard that vocabulary before. It's well, I'm going to try to use all the vocabulary I can.
Hey, Mr. Cole.
Oops, that should have rounded that wrong. It's a 6. What do you guys think? Okay. Let's look at example 8. Now, something fundamentally different is happening here. If the mean of a normal distribution is 85, determine the standard deviation if we know a z-score of 0.8 has a value of 93. That's our z-score formula, right? So we're just going to solve for sigma. What'd you get? Hopefully 10. I multiplied both sides by sigma to get it out of the denominator and then divided by 0.8. Just did algebra, algebra 1 type algebra. You could subtract the 93 and 85 first if you wanted to.
Sometimes I need a reflection.
I just wanted to like be clear. I didn't do anything sneaky, right? That's all I was trying to say. I wasn't trying to like insult you by saying you forgot how to do algebra 1 algebra. I know that you know how to do it. I'm just saying that like I did the most obvious thing you could possibly have done. That's what I'm saying.
Right.
Like nothing sneaky happened. All right. Let's take a look at one of these. So it says, given a standard normal distribution, how do I know it's standard normal? N01. Provide a sketch of the indicated area on a normal distribution curve, then use your GDC to find the value of A. Round to 3 sig figs. So notice here, this is a different question, right? We're asking for, we're given the probability and we're asking for the score or the measurement, right? So the way we find this with our calculator, so second vars, I'm going to be using the inverse normal function. So that's option 3. The area, 0.335. Our mean and standard deviation are our standard normal. So nothing odd here. I get just negative 0.46. Oops, 426. Now, the inverse normal is only going to work if that's a less than. So notice what's happening on the next problem. It's greater than. So that's going to be the same thing as 1 minus. Right? Everybody's okay with that? If I take the greater than, I can just write as 1 minus less than or equal to. So if I do a little bit of algebra, I can subtract 1 from both sides and then divide by negative 1. And that number is 0.28. So that's what's going to go into my calculator. So I have there 0.583.
It can be legal, but it's not like.
But like, she
It
can't
makes us
give us,
a-
she gives us work. I thought she was giving us work to do.
Hi, guys.
Get rid of the tail thing. Or do which one do I click?
Do you have a tail? I don't have any tail.
Am I clicking the wrong thing?
So you did inverse norm?
I didn't even do it.
What's
Yeah, I have a tail.
Ooh, this might make your life way easier.
I don't know how to pick a tail.
So, everybody else, you guys have tail? Okay,
Yeah.
so Megan's, do you guys have tail when you do inverse norm? When you press the inverse norm on your calculator? If you do, it looks like you can pick whether you want it to be greater than or less than or equal to on yours. So if it's greater than A, your tail should be going right.
How can you pick the tail?
Well, her calculator has an option under inverse norm. Mine did not.
Mine does not.
Yours does not, so you have to do it the way that I showed you. But you can,
Tail left.
you just,
Oh, then I can just type that in.
well, this would be right.
Well, yeah, no, but I'm writing it in my note.
Yeah. Left is less than, right is greater than.
And then if it has the
Center is what we're doing next.
Oh, which is, what do I call
I think that's center.
it? Yeah, but like what is it? What kind of
It's called a compound inequality or an and inequality.
If you want the
All right. For everybody else, shh. So if I want the stuff between A and negative A, that should be
Oh, yeah, that's what I'm trying to say.
we can say that, right? I don't know why I wrote 0 there.
Because you want to have more money on the liabilities and equity side versus
No, that's not at all what I want to write.
That was one.
I want to write that.
What I do? They said it's one whole thing. Oh, yeah.
so any
Focus in here for just a couple more minutes on math. So I can rewrite the probability from negative A to positive A as the probability from negative A to 1 or to 0, excuse me, and then from 0 to A, right? Everybody's okay with that? Since it's symmetric, that also means that this is just like 2 times the probability from 0 to A. And that's going to equal, I want to do the other way. I want the other one. I want negative A to 0. Okay. But that's still equal to 0.36, right? I divide both sides by 2. So there's my 0.18. Now, what we're saying here, so if I draw my normal, let me draw a picture to kind of justify this. I have my normal curve, there's 0, here's negative A, and I want this part of it, right? That part is 0.18. So what does this part have to be? 0.5 minus 0.18. Excellent. So 0.32. And that's now something I can inverse norm on my calculator. So negative 4.68. Oh, see you later.
I originally scheduled it for this morning, but
Yeah, obviously that had to get rescheduled.
yeah.
See you later. Oh my God, this just keeps on going and going. All right. So we have 5 minutes left or something, right? At this point, you guys should have enough to start like doing homework. And again, please actually try this homework assignment. Like at least enough, like if there's parts like A through Q or whatever, like at least do enough of them on the calculator so it's like, okay, I've gotten like 6 of these in a row. I know how to do this question. I'm going to just move on before you start copying things out of the back of the book. Right? We'll finish these in-class examples up because there's some like, look at some of this nasty looking stuff here. And some like story problem kind of things. So we still have a bit more I want to do together on this. And then we'll do the activity in class. And we'll take the quiz on Friday. And then probably have the test the following week. Does that feel okay?
What are we doing Wednesday?
We're going to do the rest of this and do the activity. And then we'll take the quiz and the test the next 2 class periods probably. So like as you're working through homeworks or whatever and you have questions on stuff, like come with questions. We can do stuff the next day. Like if you saw something like, I don't know what to do with this thing, we can talk about it. Okay? Everybody good? Well, good enough? You're done listening to me, it seems like.